Yes, technology is so fun. You're on.
So it's nice to see all of you again this morning. My name is Droby, and I'm part of the English Lab for Multiple Sclerosis. And I would like to take this opportunity this morning to give you a glimpse about our research activities that are being carried out in the lab, which mainly focus on investigate the relationship between tissue damage and clinical disability in MS using cutting-edge MRI techniques. One example of this is a study that we have recently concluded in the lab, which aim to assess measures of tissue damage both at 3T and 7T MRI field strength in order to identify better correlates with disability across the different MS phenotypes. Most of you are well familiar with the 3T MRI scanners, which are now mainstream used in all MS clinics all over, but a 7T is gaining popularity now because it allows us to depict the brain compartments in more higher and finer resolution. And with this enhanced spatial resolution of the 7T, we can acquire images with finer details. And using this method, subtle brain abnormalities can be detected, and this will help us to better diagnose and monitor this disease. And as you can see in the figure here on the right side, in the 7T images compared to the 3T on the top, you can better depict the lesions around the ventricles, and you can even see more subtle stuff that are going on here that you normally will not see on the 3T image. And if you compare the structural image, these two one, you would see that the bottom one is more finer and sharper. Another study that we have recently started is focusing on studying MRI predictors of disease and disability progression in African Americans with MS. Now, this study we are conducting in cooperation with Columbia University, and and it could be considered one of its kind to systematically study or address the question, why is MS more aggressive in African Americans compared to Caucasians? So the state of knowledge on this topic to date is that African Americans show less frequent MS cases compared to Caucasians, but the disease course is more aggressive in this community compared to Caucasians. Two studies tried to answer why is that, and they suggested that it might be related to more extensive white matter damage. But we know that there are more factors, for example, spinal cord lesions and cortical lesions that play a major role and impact on disease disability that have not been yet studied in this subgroup of MS patients. So our aim in this study is to first understand the mechanisms leading to worse physical and cognitive disability in African Americans with MS, to identify predictors of more aggressive disease progression in African Americans with MS, and to help the development of tailored therapeutic clinical interventions. And we're quite optimistic and hopeful that insights that could be derived from this study could be translated into the normal care practice to better address this topic or issue. A third study that we are recently, so I should state one more thing about this study. So it's currently ongoing, and we're recruiting participants. So if you're interested, feel free to reach out either to me or to Dr. Klinova. and we will happily give you more information about it.
5-minute warning.
Okay. The third and final study that I will present to you today is focusing on examining the role of brain sodium content NMS using MRI. And we know that there are already evidence showing that sodium accumulation into neurons do actually occur in MS, and it increases the risk of neuronal degeneration and irreversible clinical deficits. There are now specific non-invasive MRI techniques that are available which allow us to measure the quantification of sodium inside the neurons. So the aim of this study is to early detect increases of intracellular sodium concentrations in order to prevent irreversible neuronal damage by delivering suitable treatments such as sodium channel blockers. I have to state a very important thing about this method. It's performed both at 3T and 7T MRI, and it is totally non-invasive, so there are no injection of radioactive agents whatsoever. And finally, I would like to thank all of you for coming here today and for your continuous support and participation in all of the ongoing studies so far.